Hello everyone, this is Mr. Underkoffler. Today we're going to be looking at the guided notes called Composite Figures, and we are going to split this up into two separate videos, so this is part one. Okay, what is a composite figure? It is one that cannot be classified as a single polygon or circle. To find the area of a composite figure, we're going to have to separate the composite figure into shapes whose areas you know how to find. Let's take a look at our first example, problem number one. As you can see, this shape has 6 sides. We do not have an area formula for an irregular hexagon, which is what this thing would be called. We don't have a formula for that on our formula sheet. So to be able to find the area, part 1A, we're going to have to break this down into 5 steps. Step 1 is we're going to draw the shapes that come from this composite figure, whose areas we would know how to find. And so, quite simply, if I take a line and I draw it straight across here, you see I'm going to have a trapezoid on the top and a rectangle at the bottom. So that's the first thing I need to do. Separate this and maybe quickly sketch the shapes that we actually do know how to find that can come from this composite figure. Step 2, we're going to write down the formulas to get the area of each of these figures, and these formulas are straight from your formula sheet. Step 3, we're going to have to label the parts on our drawings with the measurements needed for their area formulas. So you will recall, for base 1 and base 2 of a trapezoid, they are the parallel sides. So that would be the 16 and that would be the 33. And I was able to figure out this was 33 because if the bottom of the shape is 33 and that stretches the whole way across, then that would also be my base 2 going across here. No problem. Now, for the height, that's going to be a little bit trickier. For the height, I'm going to have to take the total height of 30 meters and subtract away the height going this way, which I can see is 21 meters. That will give me the height that remains for my trapezoid. And we're going to practice again this idea on the second page of our guided notes. So this is what I did to get the height. 30 minus 21 gave me a height of 9. The measurements of the rectangle were pretty easy to see here. It is obviously 21 meters wide. It is obviously 33 meters long. So I went ahead and I labeled my rectangle with those drawings, with those measurements. All right, step 4. This is the easy part. We're going to do formula, substitute, solve, formula, substitute, solve. We're going to do that for as many shapes that we had drawn to get the area of each of those individual shapes. After I get those areas, step 5, add the areas together. So since we separated our composite figure into 2 separate shapes, we're going to take the areas of those 2 parts, add them together to get the full area. We will round to the nearest tenth if necessary, or round to the nearest hundredth if necessary, whatever the directions tell us to do. That is what we're going to round to. Okay. Now, to find the distance around, this is at the bottom of your page, to find the distance around a composite figure, we're going to have to figure out the measurements of all the sides. And when I say the sides, I mean the actual exterior sides on the outside, not just heights of things that aren't actually sides. We will have to add those measurements together. Now, if we do have a semicircle or a circle, to get the distance around those, you would have to incorporate circumference. Now, that's not the case here. Here we have all straight edges. So most of these measurements for these straight edges were given to us except for this one. So pencils in your hand. If this is 21 meters going up and down here, then it's 21 meters going up and down here. Now, do you see which measurement here is not an actual side of this composite figure? It would be the 30 meters. 30 meters was the total height of the entire composite figure, but it's not an actual side of the shape. So we would not need that to get the distance around. We just have to add all these measurements together. Let's go ahead and write this down. So the 12.4 plus the 16 plus the other 12.4. You can see I'm kind of going here in clockwise order. You can go in any order you want. As long as you get all of these outside measurements added together, you're good to go. So quickly, go ahead, hit pause temporarily, enter this on your paper, write it down on your paper, and then enter it into your calculator. What do you get? And you should have got 118.8 Something you should note, distance around, which is the idea of perimeter, is regular units. So this is not square meters. This is regular meters. If you go back to 1A, this was square meters because area is square units. So that's something we need to remember moving forward. Okay, let's turn to the next page. This next page is all about finding measurements that are not directly given to you on the shape, but that are needed for the area of the different pieces that make the composite figure. So for example, on this composite figure, we have a rectangle, those measurements are already given to us. We have a triangle, I can easily get the base, that's 33 feet, but I don't know the height. You can quickly draw this right now with your pencil. I don't know that height. It's not given to me directly. What I am given is the total height of 25 feet and this up and down measurement. So think about this. To get up and down measures, you might have to subtract a total up and down measure by another up and down measure. And that's exactly what I'm going to have to do here to get the height of this triangle. Now, I already have this typed up for you. 25 minus 11, up and down height total, minus the other up and down height. That gives me the height I need for my triangle. And then sometimes you're going to have to get a little creative with diameter and radius. What's the rectangle's width? Now, the rectangle's length, that is already given to us, 28 yards. So I already have that. But the width means going across here. It's not given to me. But if you can recognize radius, two radiuses will give you the diameter. I already have this highlighted here on my screen. If it's not highlighted on your paper, you might want to highlight on your paper or maybe underline it, put a star next to it. 2 times radius will give me the diameter, and the diameter of the semicircle is equal to the width of the rectangle. So 2 times 6 would give me 12. That's not only the diameter of the semicircle, that coincides to also being the width of the rectangle. And sometimes you might have to go the other way. Maybe sometimes you would have to take diameter divided by 2 to get the radius of a semicircle. So please remember the relationship of diameter and radius, because if a semicircle is involved on a composite figure, it's pretty much inevitable that you're going to have to use the relationship of diameter and radius at some point. Okay, so the rest of this page, follow along. It says the following problems each show a composite figure with a line segment drawn to separate the figure into shapes whose areas we know how to find. Show the work, whether you add, subtract, multiply, or divide, to find the missing measurements. Okay, I'll do the first one with you. It says, what measurements are the base and height of the triangle? Okay, you can see where the triangle is. Here's our triangle. We need the base and the height. Now, the height is normally a dashed line. Remember that? And it meets at a right angle to the base. So please don't think base is always at the bottom. This triangle has been rotated, where the height is now going this way and the base is now going this way. So I got my base. It's already here. The width on the left of the rectangle will be the width on the right of the rectangle, and that is my base. Let's go ahead and write that down. No work needed for that. We just had to be observant. Now, for the height, this one's going to be trickier. This height is going sideways. So I need the total sideways length minus the remaining sideways length to give me the length I need going across for the height of this triangle. That's what we were just talking about up here. Now this one was going up and down to get the height up and down. Here our height is left and right. So a left and right total minus this left and right distance will give me the remaining distance I need for my height. So let's go ahead and write this work down. We are taking the 137.5, subtracting away the 97.5. Go ahead and write that down underneath the answer blank. Use your calculator if you need to, although this one's kind of nice. You see how they both end with 7.5s? So boom, that's going to give me 40 centimeters for the height. Okay, I want you to try the next ones on your own. And you're allowed to look back at the top of the page. Remember the tricks we talked about with radius and diameter? That might come into play coming up on a future problem. Spoiler alert. So do the next three problems on your own. This one here, which is a rectangle and a trapezoid. This one here, which is a square. You can see all sides are the same. And a semicircle. And finally, the rectangle and semicircle. All of the next three problems. Try them on your own. So hit pause on this video. Figure out the missing measurements. Then hit play when you're ready to see how you did. Okay, did you already do the next three problems on your own? If not, you better hit pause now. Okay, we need to get the measurements of the trapezoid. Well, I already know that the bases of a trapezoid are the two sides that are parallel to each other, and one of them I already have, 34 feet. So that can be called your base 2 or your base 1. I really don't care which one you call it. But the other base is not just 9 feet. 9 feet only goes, let me change colors here. 9 feet only goes from here to here. That's not the full length of base 1. Oh, the 15 feet goes from here to here. Oh, so I need to add those measures together. The left and right length up here, the left and right length right here. 15 plus 9, that is going to give me the measure of base 1, which is 24 feet. Okay, now for the height. The height would go up and down between these bases. I'm going to go ahead and draw that right now, meeting at a right angle. How do I get that up and down value? Well, I know the total up and down height is 21.5 feet. I know the up and down measurement here is 12 feet. So this is the idea we were talking about at the very top left-hand corner of this page. Total up and down distance minus this up and down distance will give me the up and down distance that I need for my height. And that's the work you should have shown. 21.5 minus 12, boom, gives me 9.5 feet, 9.5 feet. Okay, how about this one? What is the radius of the semicircle? Radius would go from the center of the semicircle, which is actually here, to any edge. I'm just going to go ahead and draw it straight up. It doesn't really matter which way you would draw it. How am I going to get that? Well, I know the diameter. The diameter is the whole way across, and that would be the same as this length here. Because this is the cool thing about a square. If you see these little tick marks on all four sides, this means this is a square. All four sides are 18 meters. So if I take 18 meters, which is the diameter, and I cut it in half, I either divide it by 2 or multiply by half, boom, that will give me the radius. So you have to understand the relationship of diameter and radius to do semicircle type of problems here that are part of a composite figure. And here's another one. Now this one's a little interesting. How tall is the rectangle? This was the trickiest problem on this page. How tall is the rectangle to be from here to here, which is the same as here to here? Oh, that's the diameter. But wait, they didn't give me the radius. They didn't give me the radius of the semicircle. But wait, I know the total length across left and right is 119. I know the length from here to here is 92. So this is going to take 2 steps. If I subtract total length minus this length, I'm talking about the left and right measurements, that will give me the radius, this right here, of 27 centimeters. And if I know the radius, I can double it to get the diameter. And that's gonna be the width of the rectangle, how tall this rectangle is. It is the diameter. So there you go. That one was a little tricky, but I'm gonna give you a spoiler alert. You will need that skill in order to do some of the problems, at least one of the problems, coming up on the next page. Speaking of the next page, that's how we're going to finish this video. You're going to try 2, 3, and 4. you're going to have to use some of the skills that you learned on the previous page. Sometimes you might have to subtract. Sometimes you might have to deal with radius and diameter, where you either multiply to get the diameter or divide to get the radius if you can get the diameter. You might even need to add measurements together to get total length going across. So the skills we just practiced, you are going to need to use on numbers 2, 3, and 4. And if you're already feeling stuck on number 2, I'll start you off. We can make this composite figure become a trapezoid at the bottom and a triangle at the top. You just have to figure out what is the base 1 and the base 2 of the trapezoid, what's the height of the trapezoid, what's the base of the triangle, what's the height of the triangle. Some of those measurements are going to be really easy to get, and at least one of them is going to take a little bit of work. Not much work, but similar work to what we were just practicing on the previous page. So, after you figure that stuff out, then you will be able to use the area formula of the trapezoid, the area formula of the triangle. You'll substitute the numbers in. You will eventually add those two answers together to get the total area of this composite figure. So there you go. I kind of got you started on number 2. I want you to now hit pause. I want you to finish number 2 on your own. Then try problem number 3. Then try problem number 4. Okay. Hit pause, do 2, 3, and 4, then hit play when you're ready to see how you did. Okay, problem number 2. Let's see if you figured this out. The height of the trapezoid was pretty much already there, 6 feet. The base 2 at the bottom was already there, 15 feet. Base 1 is the total length across, which they already gave me right there, creatively. So that is 21, and that's also going to be the base of your triangle, because that went the whole way across, which we already had that measurement right here. To get the height, now this is the trickier part. To get this up and down height, you're going to have to take the total up and down height of 15 and subtract away this up and down measurement of 6. So 15 minus 6 gives me 9. That's the height of my triangle. If you mess that up, feel free to hit pause and fix your work. Okay, from here, formula substitute solve. Hopefully your parallel bases were B1 and B2. Hopefully your height of 6 was your H. Use your calculator. 21 plus 15 is 36. Multiply to the 0.5 and the 6, and you will get 108. By the way, I like to make my 1/2s become 0.5s. If you want to keep 1/2s, that's fine. For the triangle, we got our base of 21. We got our height of 9. Formula substitute solve. That is going to give you 94.5 or 94.5. From here, you will add them together and get 202.5. Did you put a little 2 for square feet? If you need to hit pause and fix your work, feel free to do so. But I'm going to go ahead and move on. Problem number 3. We obviously have a rectangle and a semicircle. You could almost argue that you don't even need to redraw them. They're kind of already right here. The rectangle's measurements, pretty easy to see, 28 and 42. But the radius of the semicircle, which we do need to get area, if you look at the area formula, pi times radius squared, for a full circle, you need the radius. How am I going to get that? Well, if I get the diameter, which I already have, is 28, and I divide that by 2, because diameter divided by 2 will give you radius. Boom. You will find out the radius is 14. If you didn't figure that out, feel free to hit pause and fix your work from here. Okay, for a semicircle, it's not just pi times radius squared, because a semicircle is half of a circle. So you have to somehow adjust your work to make it half of the area of pi r squared. Real simple. Just multiply it by 1/2. Or you could even divide by 2. All right, did you substitute correctly? 14 was our radius. You have to somehow either divide this by 2 or multiply by 1/2. That's going to give you 98 pi. Now, I know you might have got the crazy decimal. I would not write the crazy decimal because that's going to require you to round. You don't want to round until the very end. Otherwise, it could actually make your final answer a little bit off. For the rectangle, area equals length times width. This is really easy, 42 times 28. That's going to give you 1,176. Add these measures together, and you will get the total area. If you do round to the nearest tenth, like you're supposed to, according to the directions at the top, the 7 is big enough in the hundreds to make the 8 round up. So 1,483.9 square inches. This one was not feet. This is square inches. If you need to hit pause to fix your work, please feel free to do so. Finally, problem number 4, we obviously have a triangle and a semicircle. Again, you could kind of argue that you don't really need to draw them because it's already there. 48 feet is definitely the base, but how do we get the height? This was the trickiest one on the page. You are actually going to need to get the radius before you get the height, and here's why. We know the radius could be from here to here. We know the total left and right distance of 64 feet. We know from here to here is 48 feet. So you can subtract the total left and right distance by the 48 feet left and right distance, and that will give you the left and right for the radius, which is 16 feet. And now that you have the radius, you can double it to get the diameter, and the diameter of the semicircle is going to be the height of your triangle. This is actually a right triangle, so there is no dashed line for the height. Well, I guess there technically was on the drawing. Okay, anyway, 16 times 2 gives you a height of 32 feet for the triangle. If you already messed up, feel free to hit pause and fix your work. Okay, from here, area formula of a triangle, area formula of a circle. Oh wait, we don't need a full circle. We need half of a circle. It's a semicircle. You need to multiply by 1/2. Formula substitute solve. Here is your work and results for the triangle. Formula substitute solve. Remember the radius was 16. That's what we're taking to the second power, which I believe is 256. Times a half is 128 pi. Again, I would not get the ugly decimal yet. I would keep it in terms of pi, so that way you will not have to round until the very end, which is the way you want to do it. Add these together, and this is the answer you're going to get. And yes, the 2 in the hundreds does not make the 1 round up. So there is your final answer. Make sure you have square feet. All right, that concludes part 1 of the guided notes on composite figures. Part 2 will be a separate video. Thank you for watching this one. We'll see you next time.